differentiation or derivatives. Okay, this power rule is majorly concerned with how to derive the derivative or differentiate a given function. So now, let's say we have a function. Let's say we have a function f of x. F of x is used to denote a function. F of x means function of x or y. So let's say we have a function f of x or y, and let's say y is equal to x raised to power n. This y is the function of x. When we say function of x, what we mean is that x is the independent variable, while y is the dependent variable. Function of x means depending on x. Y is depending on x. That's what f of x means. F of x means y depending on x, or just simply y. So the power rule is that if y is equal to x raised to power n, okay, to differentiate this, dy over dx, dy over dx means differentiate y with respect to x. Change y with respect to x. Why are you changing y with respect to x? So changing y with respect to x because y is depending on x. For instance, now most students are being sponsored by their parents, right? And for you to go to school, your school fees have to be paid, and your parents have to pay your fees, right? It means that you are depending on your parents. So in this case, y is you, x are your parents. So it means that anything that happens to you, or anything that should be done with you when you are still under your parents must know about it. If someone wants to come to the house and say, hey, I'm coming to the house, I came to your house and I saw a beautiful flower in the garden and I decided to pluck it. Okay? Now, you will not just come to the house and pluck, come on, flower, come here, drag flower and go away. No. You must be giving what consent. Okay, yes, it's good, your eye is good, you saw a beautiful flower, right? Or you are giving you permission to pluck. What it means is that y, which is you are depending on your parents, you're a function of your parents. So before anything will change as regards you, x must be respected. Y changing y with respect to x. So that's what dy over dx means. That is the general idea of derivatives or differentiation. So it means that dy over dx will now be equal to, now this n you're seeing here is the power, x is the variable. So what do you have to do? You say n times x raised to power n minus 1. N times x raised to power n minus 1. Alright? So what it means is that you bring down your power, you multiply it by the variable x, and you subtract 1 from your power. Now let's look at an example. Let's say for instance we have y equal to x raised to power 3. How do we differentiate this? Very simple. dy over dx will be equal to, carry your power down, say 3, write your variable x, then subtract 1 from your power, 3 minus 1. So this will give you 3x squared. Now if you have y to be equal to 4x cubed, for instance, you say your dy over dx will simply be 3 times, the coefficient here is 4. In this case, our coefficient was 1. That's why we multiply 3. We just multiply 3 straight, but 3 times 1 is still 3. So when you're multiplying your n by your variable, it must affect the coefficients there. So in this case now, we are now having a coefficient of 4. So 3 times 4, so we say 3 times 4 x raised to power 3 minus 1. So this will be 3 times 4 is 12, so our answer is 12x squared. 12x squared. Now let's look at another example. Let's say we have y equals to, let's say, minus 3x raised to power 7, for instance. You have a negative coefficient here. So now this will be 7 times minus 3, x raised to power 7 minus 1. Your power times your coefficient. Repeat your variable x, then subtract 1 from your power. So this will now be minus 21x raised to power 6. Okay? So this is how to apply power rule in differentiation. Now we can also have a fraction as our power. Something like this. Let's say y equals to 14x raised to power 1 over 2. 14x raised to power 1 over 2. This will still be the same pattern. You carry your power to get your y over dx. Remember, this is the y over dx result. To get your y over dx, you say 1 over 2 times 14, then x raised to power 1 over 2 minus 1. Always multiply your power by coefficient and subtract 1 from your power. So this will be 2 here 1, 2 here 7. 1 over 2 times 14 will give you 7. So 1 times 7 is 7. So 7x raised to power 1 over 2 minus 1. Let us go over here. The answer is minus 1 over 2 though. But let us check. 1 over 2 minus 1 over 1. LCM is 2. 2 into 2 is 1. 1 times 1 is 1. Minus 2 into 1 is 2. 2 times 1 is 2. 1 minus 2 is minus 1. So we have minus 1 over 2. Minus 1 over 2. But now, please, whenever you have a negative power, don't leave your answer like this. Whenever you have a negative power, don't leave your answer like this. Okay? You can simplify it further. What do I mean? Look at this, guys. 7x raised to power minus 1 over 2 is equal to 7 times x raised to power minus 1 over 2. Am I correct? Do you agree with me that 7x raised to power minus 1 over 2 is 7 times x raised to power minus 1 over 2? Beautiful. Now, what am I saying in essence? Alright? 7 times x raised to power minus 1 over 2 is this. 7 times 1 over x raised to power 1 over 2. Do you agree with me? Because anytime you remove this minus sign, it becomes division. For instance, now, let me give you a very simple example. For instance, now if you have x raised to power minus 2, x raised to power minus 2 is 1 over x squared. So if you remove the minus, it's division 1 over. X raised to power minus 5, 1 over x raised to power 5. Are we together? So that's how we also have x raised to power 1 over 2 there. Because the sign has actually been removed by virtue of changing it to division. So this will now be equal to 7 times 1 is 7. So you have 7 over x raised to power 1 over 2. 7 times 1, 7, then over x raised to power 1 over 2. Now, whenever you have a variable or a constant raised to power half, it is the square root. If you have, let's say 36 raised to power 1 over 2, the answer is 6. How? 36 raised to power 1 over 2 is square root of 36. If we have 36 raised to power 1 over 3, cube root of 36. Are you getting it? So, if you have 36 raised to power 1 over 4, it is quadratic root of 36. So when you have x raised to power 1 over 2 here, this will now be 7 over root x. This is your final answer. Dy over dx. Dy over dx. So this is the general idea or general concept of the power rule of differentiation. Alright, so we'll be looking at the product rule, and it's very important to note that when you are differentiating a constant, okay, when you are differentiating a constant, before we look at product rule, when you are differentiating a constant, it's important to know that constants are numbers. 5, 6, 1 million, okay, let's say 5 over 20, 2 over 5, fractions, anything, even minus value, minus 7, if you are differentiating any constant at all, the answer is 0. No matter how large that constant is, it is 0. Now let's delve into the product rule. Now please take down. Now the product rule of differentiation, is used to find the derivatives of functions, to find the derivatives of functions which multiplies themselves. To find the derivatives of functions which multiplies themselves. Which multiplies themselves. Full stop. Okay? Now, given that y is equal to uv, like in this form, this is the form of functions, u times v. This means u times v. This function 1, this function 2. When you have two functions multiplying themselves, that is where you apply what rule? Product rule. Thank you. That's where you apply product rule. So it is sacrosanct to understand that you should have only what? Two functions. The first one must be your, the second one must be your v. First one u, second one v. Now to find the y over the x here, the product rule is giving us u dv over dx plus v du over dx. This is the formula for product rule. U dv over dx plus v du over dx. Now, u is the first function, v is the second function. dv over dx means differentiate v with respect to x. du over dx means differentiate u with respect to x. It's just like cross multiplication. U times the differential form of v plus v times the differential form of u. That's the idea. Alright, that's the idea. So now let's look at the basic example. So but please don't forget, it's very simple. The y over dx is equals to u dv over dx plus v du over dx. Don't forget that. So now look at these guys. So if we have, let's say, for example, if we have y equals to 2x times x plus 3. These are two different functions multiplying themselves. Given that y equals to 2x times x plus 3, now find dy over dx. Now in simple algebra, for instance, algebraic expansion, when you see something like this, you just do 2x times x, 2x squared, 2x times 3, 6x. What is your answer? X squared plus 6x, and that's your answer, right? But you will not do like that here. You will not just jump into expansion. You have to first of all arrange them. Your first function is what? Your second function is what? V. So you do like this. You say u equal to 2x, v equal to x plus 3. In the formula, you have dv over dx and du over dx. So you find your du over dx and you find your dv over dx. It will be important to arrange them like this. Place your du over dx under u. Place your dv over dx under v. So du over dx means 2x. Differentiating 2x is 2. How? Because differentiating x is equals to 1. So it's like you say 2 times 1 equals to what? 2. Remember, I said something about differentiating constants to be equal to 0. That doesn't mean that you say differentiating 2 is 0 and x is equals to 1. So 0 times 1 is 0. Wrong. Why? Because 2 and x are together. It's not 2 plus x, it is 2x. 2 plus x is even 1. Because 2 is 0, x is 1. But 2x is equal to what? 2. So whenever you see a coefficient with x that doesn't have a power, throw away the x. Collect only the coefficients. No matter what the coefficient is, even if you have 1000x or 1000 y, although this one is a different case altogether, when we look at this differentiation, I will tell you how to differentiate with respect to y. But 1000x is just 1000. Remove this x because it doesn't have the power. If x has the power of 2, you know in our power rule now, 2 times 1000 will be what? 2000 x. But when x doesn't have the power, just remove the coefficient. Just remove x rather than write the coefficient. Do you understand? Is it clear? Just remove x, write only the coefficient. Now let us go here. Differentiating x is what? 1. When differentiating x, what do we get? 1. Differentiating 3 is what? 0, because 3 is a constant of. As it is now, you'll be able to get all you want to differentiate this function accurately. There's no other rule you can use in differentiating this function apart from product rule, because these functions are multiplying themselves. So there's no other rule. So 2x, x plus 3, 2, 1. So you have been able to arrange them accordingly and you have gotten what you want to get. So what do you do here? You just apply the formula, alright? Apply the formula that you have. dy over dx is equal to, your u is 2x, dv over dx is 1 times 1. U is 2x, dv over dx is 1, just like it cross multiplying. This times this plus this times this. 2x times 1 plus what is b? X plus 3 plus, just bracket these guys, x plus 3 dv over dx is what? 2. Then you multiply. So at this point now you expand. 2x times 1 is 2x plus, work on these guys, x times 2, 2x, 3 times 2, 6, 2x plus 2x like terms, 4x plus, this is your final answer, 4x plus 6. This is your dy over dx. So you must understand the different components of your product rule. Get them, employ them into the formula by substitution. So, here a final answer. Does that make sense? Yes. Alright. So, that is that. So, I want you to try this. If you have, let's say, y equals to 4x squared plus 6x minus 3 times 2x minus 18. So try this. So find dy over dx. Find dy over dx for this. Alright? Find dy over dx. Quotient rule. Alright? Looking at quotient rule. So from the word quotient has to do with fractions. It has to do with division. Are we together? It has to do with division. When you get the word quotient, you need to understand that it is related to the word division. Quotient of 2 and 5, okay, it's like 2 over 5. Quotient of 1 and 2, 1 over 2. Do you understand? So, quotient rule, please go down. The quotient rule of differentiation. The quotient rule of differentiation is utilized in finding the derivative. The quotient rule of differentiation is utilized in finding the derivatives of functions which divide themselves. I'll take it again. The quotient rule of differentiation is utilized for finding the derivatives of functions which divide themselves. So when two functions are dividing themselves, the rule to apply is what? Quotient rule. I told you that for product rule, when two functions are multiplying themselves, that's when you use product rule. When we see this over this, automatically the rule to use is what? Quotient rule. Now, okay, so the quotient rule is giving us, follows. The quotient rule is giving us follows. The quotient rule is giving us follows. So now, if y is equal to u over v, now u is the first function, v is the second function. This is the form it takes. Sometimes you see something like this, f of x all over g of x, or something like this. This f of x is one function, g of x is another function. So if y equals to u over v, or f of x all over g of x, dy over dx will be equals to v du over dx minus u dv over dx all over v squared. This is the formula for quotient rule. V dv over dx minus u dv over dx all over v squared. Remember product rule. Product rule is u dv over dx plus v dv over dx. There is no divided by v squared anyway. Alright, so this particular one is represented like this. Our u still remains our first function. Our v still remains the second function. Don't forget that it will not change. Given that v is appearing first doesn't mean that v will be the first function. No. V is still second, u is first. Now, look at this v squared. There are some rules that apply to this guy down here. Whenever a function v has multiple entities, don't expand. For instance, if v is 2x plus 3, please, you have 2x plus 3 squared, am I correct? Right? Don't come here and say 2x plus 3, 2x plus 3. Don't expand this guy when there are two entities in your v. The only time you can expand is when you have one entity. For instance, now 2x is one entity. 4x squared is one entity. You can expand. But don't expand. Why shouldn't you expand? You shouldn't expand because it would affect the simplification of the entire derivative. Because the idea is to ensure that you simplify it. But if you want to break this down by expansion, you will be tempted to want to cancel with what you have at the top, and it can affect your answer. So when you have multiple entities as your v, just write your 2x plus 3 squared and leave it like that. You get a final answer. But if you have 2x, alright, you have 2x times 2x will give you 4x squared. If you have 4x squared, for instance, 4x squared times 4x squared will give you 16x raised to the power 4. Alright? So it is only when you have one entity that you should what? Expand. We'll look at an example. Alright? Now take this example. Take down this example. Now, given that y is equals to 2x squared divided by x cubed. 2x squared divided by x cubed. Find dy over dx. Normal algebra, you cancel x squared, x cubed, x squared. X will remain here, right? So you have 2 by x, is it not? That is normal algebra. But it's not normal algebra you're doing here. It's not algebra and trigonometry. You are doing differentiation, which is calculus. So I told you that whenever you see a function y in this form, when you have one function dividing another function, u over v, f of x over g of x, please, what you apply here is quotient rule. Does that make sense? Alright, so now let's proceed. So you know how we did it in product rule. You have to first of all arrange. Your u is 2x squared. Your v is x cubed. Like this, then you do your dv over dx and dv over dx. dv over dx is what? 4x, right? 2 times 2, 4. 2 minus 1, 4x. dv over dx is what? 3x what? Squared. That is 3. Remember from power rule. 3 times 1, 3 minus 1, 3x squared. You have arranged it like this. So what you have to do, just substitute it into the formula and you get your answer. So we know that dy over dx equals to v dv over dx minus u dv over dx all over v squared. Right? So we have to just substitute the parameters that we have been able to obtain through this arrangement into the formula. Okay? So it means that dy over dx will now be equal to our v is x, our v comes first. X cubed d over dx, bracket this guy. d over dx is 4x. X cubed times 4x. Then minus your u is 2x squared. Bracket 2x squared. Times your dv over dx is 3x squared. You say 3x squared. Alright? Then you come here and you divide by v squared. Your v is x cubed. So you say x cubed all squared. Can we expand this entity? Can we expand it? have two entities. X cubed is one entity on its own. If we have something like x cubed plus 5, we have two entities. If we have, let's say, 2x squared plus 6x minus 3, we have three entities. If we have something like, say, 3x cubed plus 4x squared minus 9x plus 100, you have four entities. Okay, but here you have just one entity, so you can be able to like expand, okay, the entity. All right, so now let's proceed. So x cubed times 4x will give us 4x raised to power 4. Am I correct? Minus 2x squared times 3x squared. 2 times 3 6. X squared times x squared. X raised to power 4. These are like terms. Okay, then divided by x cubed all squared is we saying x cubed times what? X cubed. X cubed times x cubed give us what? X raised to power what? X raised to power what? 6. Or is it 9? How is it 9? 3 times 3. Is that the fact? Have you forgotten law of indices? You add the powers. Law of indices, if you're multiplying a, let's say xa times xb is xa plus b, is it not? If we have xa over xb, it is xa minus b, right? So it is x3 plus 3, not 3 times 3. So x raised to power 6. Are we together? So now this will be 4x cubed minus 6x, 4x raised to power 4 minus 6x raised to power 4 will give us minus what? 2x raised to power what? 4, right? Divided by x raised to power 6. We can still reduce it, right? We can still reduce it now, is it not? X raised to power 6 here, 2 remain here, right? Is it not? Yes, so we now have minus 2 over x raised to power 2. This is our final answer, dy over dx. Now, if you have two entities here, it can be very complicated to do your cancelling and all of that. That's why we say you only expand when you have one entity. Don't expand when you have two entities. So this is our dy over dx. So this is the general understanding of quotient rule. Just understand that when you have two functions dividing themselves, that is when you apply quotient rule. Know the formula. Dy over dx is equals to v du over dx minus u dv over dx divided by v squared. Don't mix it up with product rule. Product rule is dy over dx equals to u dv over dx plus v du over dx. Alright? So that is it. So quickly you will try this. So let's say given that y is equals to 4x plus 9 divided by 2x divided by 2x plus 3. 4x plus 9 divided by 2x plus 3. Find dy all over dx. So differentiate this. Alright? Chain rule of differentiation. Are we together? We're looking at what? Chain rule of differentiation. Okay? From the word chain, you would realize that it has to do with different or numerous functions, right? Numerous functions, right? When you say chain rule, the rule that is applied to numerous functions, but I'll give you the actual definition of what chain rule is all about. Okay? You know of polysaccharides. You know of polysaccharides that they are chains of sugar molecules. Okay, like of course we have the starch, we have the chitin, glycogen, cellulose. These are the four major polysaccharides. They have many chains of sugar molecules. Alright, so what is chain rule? Please put down. The chain rule of differentiation, okay, is utilized in finding the derivatives of functions, is utilized in finding the derivative of functions with higher powers. Okay? Of functions with what? Higher powers. So when you want to differentiate a function that has high power, okay, not in the Boski Paguzi, I'm talking about higher powers like when n is high. Alright, when n has a high value and you're looking at a function that has a power, okay, to differentiate that, you need chain rule. And I'm going to give you the shortcut, the very simple formula, the simplest trick to apply when you want to differentiate a function of higher power. Alright, so now please take down. Take down. Now if y is equal to ax plus b raised to power n, ax plus b plus or minus b raised to power n, the y over dx will be equal to n minus 1 times du over dx. This is the trick. Where u is equal to ax plus b, where u is equal to ax plus b. So your n, you know that n is your power. So whenever you see something like this, plus or minus, plus or minus, because it can be ax plus b, it can be x minus b. Whenever you see a function in a bracket and has the power outside, all the while we have been doing the techniques of derivative, we have been using just one function with a power 5x squared, 2x cubed, 3x raised to power 9, things like this. Or we'll say 2x plus 5. But we have not done the one that we have to put a bracket and it will be raised to power 8. Or 4x plus 9 raised to power 5. This is an example of what we mean by the function of higher power. When you have a function and you have it in bracket, then you have a power. It's raised to a certain power, n. This guy inside here is called your ax plus b. This a, this x, this b. Or ax minus b. You can have 2x minus 9 raised to power 4. You don't have to start doing 2x minus 9 into 4 places. No. No. If it were to be 2x plus 5 raised to power 2, yes, this one will be easy. You can do 2x plus 5 times 2x plus 5 is not. You can call this your u and you call this your v. Then use product rule and solve it. But in this case where you have higher powers, or maybe a power like let's say 2x plus 5 raised to power 1 over 2, how do you even do this? How do you do this? Okay? Now, you can actually simplify this in an algebraic way, but if you want to use chain rule, it will be easier. And that's why I'm giving you the shortcut to that. I'm going to be applying it right away, and I want you to pay very close attention to what I will be doing right now. Okay? Normally in chain rule, you have substitution, which is very long. Chain rule by substitution is long. So to avoid that long step for chain rule by substitution, applying this simple trick can be able to help you resolve a particular function of higher power with chain rule. Are we ready? Now look at this guy. Now let's look at an example. Now giving y equal to 2x plus 16 raised to power 7. Now find dy over dx. Now you shouldn't wait for you to be told that use chain rule. Listen, just the same way if you see 2x over 6x squared as your, let's say, as your y. Do you need somebody to tell you the rule to apply it? What rule will you apply? Quotient. If you see y equals to 6x plus 9, 2x plus 15. What rule? Production. So by the time you have been acclimatized with the rules and techniques of differentiation, immediately you see a function, you would know the technique to use in finding the derivative of that function. Now we have a question before us. We are given y equals to 2x plus 16 raised to power 7. How do we resolve this using our chain rule trick? The trick that I have for you, the shortcut I have for you to enable you get the derivative of this function. Now your y is equals to 2x plus 16 raised to power 7, right? Remember I told you that the formula for dy over dx, from the chain rule of this, dy over dx is equals to n times u raised to power n minus 1 times du over what? Dx. Times du over dx. So you have to first of all state what u is and what du over dx is. You don't have v here. In this one you don't have v. So it makes it easier. Now your u is 2x plus what? 16. Du over dx means u is everything that is inside this one, not the power. Are we together? U is not actually having any relationship with the power. U is only what is inside the bracket. Now your du over dx is differentiate u with respect to x. Differentiate this guy here. So 2x plus 16 will give you what? 2. 16 is a constant, so that's 0. Now the next thing here to apply is of course the formula. We told you that I told you that n times u n minus 1 times du over dx is the formula to actually apply when differentiating this kind of function with a higher power. So this will now be equal to n is 7, so you bring 7 down. 7 times, what is your u? 2x plus 16, put it in a bracket. Raised to power n minus 1, 7 minus 1 times what? 2. Du over dx is 2. Are you seeing it? So now this will be 7 times 2x plus 16 raised to power 7 minus 1 is what? 6 times 2. Now, you cannot multiply 7 by this. Reason is because it has a power. And you are not even expanding, you're not expecting rather to expand this guy. It's not your opinion, don't even try it. You leave it like this till you have the final answer. Rather, it is only the things that are outside that you multiply. Am I communicating? Only the things that are outside that you multiply by each other. So if you have 7 times 2, 7 times 2 is what? 14. So this will now be 14 bracket 2x plus 16 raised to power 6. This is your answer. Dy over dx. Simple. So it's only the entities that are outside the brackets, outside, that you can multiply. 7 times 2, 14. Bracket 2x plus 16. You cannot even expand. This is how it will remain. Alright? This is how it will remain. So this is the general understanding of chain rule when differentiating functions with higher powers. Alright? So you'll be trying this right away. Now if y is equal to 17x minus 5 raised to power 1 over 2. Okay? Find dy over dx. Okay? Find dy over dx using chain rule. Alright? You can also try this. Find dy over dx for this. Let's say you have minus 18x minus 21 raised to power minus 5. You have something like this as well. Okay, also find dy over dx for it. So you try it. Okay, so that is the concept of chain rule. Of natural logarithm. Alright? So take that. Now, the derivatives of natural logarithm, denoted as this is actually ln, but it's written, that L is written as I. This is called natural logarithm, ln, but like I said, the L is written like capital letter I, like I. Okay? In your calculator, this is natural logarithm, ln, natural logarithm. Okay? Now the derivative of natural logarithm, ln, okay, is expressed in the form dy over dx in brackets dy over dx of ln of x. So if you want to look for derivative, derivative of natural logarithm, it is dy by dx of ln of x, okay? But this is not the formula. Alright, this is not the formula. Now, if y is equals to ln u, okay, natural logarithm of u, dy by dx is equal to u prime all over u, or du over dx all over u. Now u prime means the differentiation of u with respect to x. Du over dx, just divide your du over dx by your u. This is like a shortcut, a very shortcut to differentiating natural logarithm. Okay, differentiating natural logarithm. So let me give you examples of what I mean. Now, let's say you have, let's say given y, look at this guys, given y equals to ln x. How do we differentiate y equals to ln x? Very simple. Now, x is your u. Whatever comes after natural logarithm is u. How together? So u is equals to what? X. Now, du over dx, you have to now differentiate u with respect to x. If you differentiate x, it will be what? 1. Differentiating x will be what? 1. So it means that your dy over dx, remember, is equals to du over dx divided by what? U. Is it not? What is du over dx here? 1. What is u? This is your final answer. As simple as that. So differentiate your u. Alright, differentiate your u and divide by u itself. And that is it. Differentiate your u and divide by u, and that is it. Now if you have, let's say, y equals to natural logarithm of x plus 9. Natural logarithm of x plus 9. This is still u equals to x plus 9, right? Now, du over dx is equal to what? 1. It's still 1 because 9 is 0. So this will give you your dy over dx, will give you this divided by this. So your final answer will be 1 over x plus 9. 1 over x plus 9. Divide your du over dx by u and you get your dy over dx. Okay, now you have, let's say you have y equal to 3 ln 2x plus 5. Okay, now this will now be, your u is 2x plus 5. Du over dx is what? 2. Now you multiply this your 3 by your, du over dx over u. So this will be 3 brackets du over dx over what? U. Your coefficient now you multiply it by, it will not be like a coefficient of your du over dx over your u. Don't differentiate this guy. Don't differentiate anything. Your only business is with your natural logarithm and what is inside the bracket. So now this will be 3. Your du over dx is 2, right? Times 2 over what? 2x plus 5, right? So your final answer will be 6 over what? 2x plus 5. Okay? 2 can go here, 1. 2 can go here, what? 3, right? So this will be 3 over x plus 5. 3 over x plus 5. That will be your final answer. That will be y over your dx. So the dy over dx. Okay? So this is the concept of natural logarithm derivatives. U prime all over u. If you have a coefficient, multiply your coefficient by d over dx over u. And of course, you will get your answer. Alright, so you try this quickly. So you have y equals to minus 1 over 2 bracket open, 30x squared plus 5x minus 3. Okay, mind you have ln here, minus 1/2 ln 30x squared plus 5x minus 3. So find dy over dx. 30x squared plus 5x minus 3. Then you have your coefficient minus 1/2 in this. Alright? So solve that quickly. Alright?